Hi guys, welcome to this two-part video series on blockchain. So in this first video we're going to have a look at how the technology works and its application to cryptocurrencies. And then in a second video we'll have a look at more ambitious applications like smart contracts or token economies, as well as analyze a little bit what it all means for a company like Ringier. So the story of blockchain, like any good story, starts with a little bit of a mystery. In 2008, an individual, or maybe a group of individuals under the name of Satoshi Nakamoto, published an article in some obscure cryptocurrency newsletter. That article described the functioning of a new electronic cash system that allowed users to exchange money peer-to-peer without any need for an intermediary like a bank. It relies on a system of a ledger of transaction, or a database of transaction, that are encrypted and stored on a decentralized network in order to enable trust in a radically new way. Because for hundreds and thousands of years, humans have relied on trusted third parties, on intermediaries, in order to enable trust. You trust your bank to keep a valid account of how much you own. You entrust your data to Google, your identity to Facebook. You trust eBay to regulate your trade with strangers. Blockchain suggests to replace all of this and trust in decentralized system, encryption, and code. 10 years later, nobody knows who Satoshi Nakamoto is, but his heritage is very much alive. With that article in a simple newsletter, Bitcoin, the first cryptocurrencies, as well as the whole concept of blockchain, were born. Bitcoin is now very far from its humble beginnings, trading at $0.005. Last Sunday, it was exchanging at over $9,000. And more than Bitcoins, people have taken the idea of blockchain and applied it to many industries and many issues we didn't have solutions to before, like a user-powered internet, or ownership of data, or monetization of content, for instance. There is real value in blockchain technologies. But last year, what we've seen is a sort of irrational hype. It went so far that some companies like Long Island Drinks Corp changed their names in order to include words related to blockchain. And this kind of strategy works. They had nothing to do with blockchain, no blockchain product at all, but their share value after this name change jumped by 200%. The situation happens so often that the Securities and Exchange Commission in the US had to issue a formal warning to tell investors not to invest in companies that just change their name to include blockchain. Everybody wants this technology, but nobody really knows what it is, and it is understandable because this technology is a real maze, and in order to understand its more complex and inspirational applications, you need to develop an understanding of the basics of how the technology works. In the last few months, I spent a few weeks researching the topic on various social media, watching hours of content on YouTube, reading white papers, attending events from the industry, signing up to blockchain products in order to create for you these videos that are a 45 minutes crash course on blockchain technologies, analyzing the different layers of complexities from the most simple, the technology, to the most complex, and analyzing the impact. So let's start with the technology itself. As I was telling you, as its heart, blockchain technology is simply a ledger or database of transactions that are encrypted and stored on a decentralized network. The data is grouped together and encrypted into those groups of data that we call block and that are given a unique identifier called a hash. The encryption that is used is called SHA-256. It has been created by the NSA, and it is a very secure system that cannot be decrypted back. What it does is it creates a unique identifier, a sort of signature for data or a file. It will always generate a 64-letter signature, and the same file will always generate the same signature. But if you change the smallest thing in the original file, like what I did here, adding an exclamation mark to the text, it will generate a completely different identifier. The way blockchain is secured is through a very simple rule. It says that a block can only be valid if it contains the hash of the previous block. So let's see what it means. For instance, here, you can see that the hash, the identifier of block 41, is contained in block 42. And it will be part of the data that is encrypted in order to generate the identifier of block 42. This will be repeated throughout all of the different blocks, linking them into a chain, hence the name of blockchain. This means that if a hacker tries to change the data, alter the data in a block, not only will it dramatically change its identifier, its hash, but it will also mean that the hash of block 41 will not correspond anymore to the identifier contained in block 42, hence breaking the chain and invalidating the following blocks. Without central authority, who makes sure that this version of the blockchain doesn't become the truth? Normally, in a normal database, a centralized server-based database, we trust the intermediary, the trusted third party, to maintain the ledger, to make sure that it doesn't get hacked. With blockchain technology, the ledger is decentralized, which means that all of the computers on the network have a copy of the blockchain and all of the transactions that are contained in the block. And those computers run very simple computer programs that enforce the rules of the network. For instance, a block can only be added to the blockchain if 51% of the computers in the network agree it's valid. That's what we call consensus. A block can only be valid if it contains the hash of the previous block, like we saw it earlier. The longest version of the blockchain is valid. A block can only be valid if it contains proof of work. So let's see what all of those rules mean and how they secure the system. If a hacker tries to compromise the security of the network and modify its data, for now, this hacked copy of the blockchain is only going to live on his own computer. But we've seen that a block can only be added to the blockchain if 51% of the network agree it's valid, which means that our hacker is going to need to broadcast his hacked version of the blockchain to the entire network. And for a little while, as our hacker broadcasts, the chain might look like this. You're going to have the original version of the chain that had been added in real time, and then the hacked version just broadcasted. And those two versions are going to live in parallel for a few seconds. But a block can only be valid if it contains the hash of the previous block, which means that all of the blocks after the hacked one are going to be invalidated. Then the longest version of the blockchain is valid, And this means that because our hacked version is shorted with invalidated block, it is going to be eliminated and the blockchain is going to regulate itself. But so what happens if the hacker tries to hack the latest block? It seems like all he needs to do is to add one more block, and his chain will be the longest one. But a block can only be valid if it contains proof of work. So let's see what that means. What is proof of work? Proof of work is a system that wasn't invented for blockchain. It was originally created to help flagging and avoiding spam emails. It is a system that forces users to spend a certain time on a task before solving it. For instance, when you're trying to create an account on a website and it is asking you to solve a shapka, to click on a little box, it requires you to spend a few seconds that a bot wouldn't spend. Of course, the proof of work that is used for blockchains and networks like Bitcoin, for instance, is a bit more complex. For the Bitcoin network, the solution is quite elegant. In order to be valid, a block's hash must start with at least 18 zeros. And we've seen earlier that any change in a block changes its identifier, its hash, very dramatically, and it is not possible to plan what the next hash is going to be. So what the people creating new blocks need to do, the people we call miners, mining new blocks is creating a new block, is they add random strings of characters to blocks in order to alter its hash, in the hope of stumbling upon an identifier, a hash that contains 18 zeros. This means that our little hacker is going to enter a race with the entire network in order to add random strings of letters to add this new block. But there is a lot of miners out there, a lot of people in this race, because adding new blocks to the chain is lucrative. Miners are rewarded with 12.5 bitcoins per block created. That amounts to over $98,000. And this means that mining has become very serious. We now see mining farms, huge factories that are filled with graphical cards that are simply adding random strings of characters to block in order to create the next one. Miners have organized into pools, groups, syndicates where people pool their resources together and share any reward that is gained by any of the syndicated miners. Bitcoin mining has become so popular that it now consumes more energy in a year, more electricity than Ireland. So a hacker is going to enter this race and he is going to lose, because with a computer like this one, it would take about a year to create a new block. For the whole network of miners, with thousands and thousands of machines working on this problem, it only takes 10 minutes. The network is therefore going to create the new block on the official blockchain. The hacker's chain is going to be shorter and therefore is going to be eliminated. The network and the blockchain is going to regulate itself. In order to unilaterally create a new block, you would need to possess at least 51% of the computing power of the entire network, which is technically possible, but very, very unlikely. That would be an enormous amount of computing power. This theoretical threat is known as a 51% attack. What I wanted to show you here is that blockchain is an extremely well-designed system in order to avoid fraud without a central authority regulating the network. And this has several advantages for an application like currencies. For currencies, it allows you to have a transparent yet anonymized ledger of transaction. You can consult, anyone can consult the content of the blocks on the blockchain, all of the different transactions that happen on websites like blockchain.info, for instance, or by downloading the blockchain on their computers. You can see each individual transaction, but the actors that enable those transactions, the sender and the receiver, are anonymized. It allows you to have a secured system through cryptography and consensus. It allows you to have a currency that is not controlled by a central authority like a bank. And we've seen that since the financial crisis, the trust in bank has plummeted dramatically. Because you don't have any intermediary, it also means that you have less costs because you don't need to pay bank fees, for instance. You also have reduced transfer times because you have one actor less in the network. That also means that because the Bitcoin network, for instance, is global, it knows no borders. An international transfer takes the same time as a national transfer, for instance. So piggybacking on the success of Bitcoins, we've seen the birth of a lot of different other cryptocurrencies that we name altcoins, for alternative coins. But maybe the biggest testimony to the success of Bitcoin is that Wall Street is now taking the technology seriously. And it is estimated that blockchain technology, by improving the processes of banks, could save them billions a year. Retailers have started to accept Bitcoin. Some very trustable actors like Expedia or Microsoft in Berlin can now order food at home using Bitcoin, for instance. And we've even seen the birth of new marketplaces whose main value proposition is to allow people to easily buy and sell products in Bitcoin. Of course, this model still has a lot of disadvantages or flaws. Cryptocurrencies are very volatile because barely regulated. Their value mostly depends on offer and demand. Transaction can't be cancelled because once an information has been encrypted into the blockchain, it cannot be modified. Proof of work requires a huge consumption of electricity. We've seen congestions in the network where the demand for Bitcoin was so high and the volume of transactions so high that miners couldn't create blocks fast enough. And there is also real cost of storage because the chain is becoming longer and longer, and as computers on the network are required to download the entirety of the chain, at some point it will take too much room on people's computers. Cryptocurrencies are still experimental, but we need to realize what has been achieved there. It is the first time in human history that people can exchange money peer-to-peer without an intermediary like a bank. After 10 years of existence, it is already amazing that the model is working this efficiently and is still alive and thriving today. So that's it for today. Thanks for watching this video on blockchain technology and cryptocurrencies. Next time we will have a look at where the value of blockchain technology really lies for companies like Ringier, which is smart contracts and token economies. So if you have any questions, don't hesitate to ask them in the Ringier International Slack, and see you next time. Bye.